All right, today we're talking about section 1.5, division of segments and angles. So some terminology you're probably familiar with, midpoints for sure, and possibly bisectors. So a point or a segment or array or a line, something that divides a segment into two congruent segments, bisects the segment. The bisection point is called the midpoint of the segment. And so the midpoint is a point. It's the point in the middle of the segment. And whatever creates that midpoint, whether it's just a point or a line or a segment or array, whatever creates that midpoint is the bisector, and it bisects the segment. In other words, it cuts it in half. So, for example, it says if line L bisects AB at O, what conclusions can we draw? Well, we have the picture right here. We could do some special markings here. We know that AO will be congruent to OB. Those two segments will be congruent. So we know that. And we also know that O is the midpoint of AB. So when we have a bisector, midpoint is created, and we know that it divides that segment into two congruent segments. So on the flip side, if we know AM is congruent to MB, what conclusions can we draw? Well, probably you're thinking M is the midpoint of AB is one thing we can say. And the other thing is we know then that that line DC, so in other words, line DC bisects segment AB. And so we do these things, both ways, because with proofs, sometimes you're given, you might be giving something as a bisector, and then what conclusions can we draw from that? Or, you could be given that, these two segments are congruent, and we need to draw the conclusion that something is a bisector. So besides bisecting, we can also trisect points, and that is when it's into trisecting, three, it's three congruent segments. And so same thing, it could be points, segments, lines, rays. Divide a segment into three congruent segments. It trisects the segment, and the 2 points at which the segment is divided are called the trisection points. So let's just draw a picture for that, because we don't have any pictures. So let's say we had segment AB here, and then we have 2 points. We'll call them, I'll try to draw them the best I can here, X and Y, so that we have this situation where they're all congruent. And so we could say X and Y are the trisection points. All right, so just like we can bisect a segment, we can bisect an angle. And so here, let's make an angle here. We'll call this angle ABC. And now let's have a bisector. So let's say there's another ray, BD, that divides this angle into 2 congruent angles. So we would say that BD bisects angle ABC. And this means that angle ABD is congruent to angle DBC. And that, and we would say BD is the angle bisector. And just like bisecting and trisecting a segment, we can bisect and trisect an angle. So maybe we have this angle here. Maybe I'll draw, oops. Maybe I'll draw it a little larger. And we are going to have, this is a little bit harder to draw. Let's see if I can do it. That's not too bad. So let's put some points here. We'll call this A, B, C, D, and E. And this is so that we create 3 congruent angles. And so BD and BE together, so let's put that in words here. We would say ray BD and ray BE trisect angle ABC. Angle ABD is congruent to angle D. BE is congruent to angle EBC. And BD and BE are angle trisectors. All right, so let's review a few, let's look at some examples. So is S the midpoint of RT? We see 2 congruent segments there. But remember, we defined midpoint divides a segment, one segment into 2 congruent segments. So this is not one segment. So this is no, because S is not on segment RT. There is no segment RT to divide in half. This is just 2 separate segments. If BD bisects angle ABC, so if it bisects ABC, it creates that. Does DB bisect ADC? So remember, you can't go by a diagram alone. So we would have to say no, that we need more info. We don't know, it looks like a square, but is it a square? We don't know, right? We're not given that information. All right, now let's see. If B and C trisect AD, okay, so we got this situation. Do EB and EC trisect AED? So again, it looks like it might from the picture, but we can't go just from the picture. So no, just because, these segments are congruent doesn't mean that the angles are congruent. Okay, so we don't know that for a fact. We don't know what kind of triangle that is. You can't go by the picture. All right, so let's see how this might look in some proofs here. So it says, let's make our chart here. Statements and reasons. So given PS bisects, so PS bisects angle RPO. So if P6 bisects RPO, it's going to create those 2 congruent angles, right? And we know that from definition of angle bisector, right? That's what we were told. So we could just go ahead and say angle RPS will be congruent to angle SP or OPS, I'll say it the way they say it. I forgot to write given. And this is a bisected angle is divided into two congruent angles. So basically, you'd say if an angle is bisected, then we know it's divided into two congruent angles. And it's basically, how we defined an angle bisector. Finally, we have EH is divided by F and G in the ratio of 5 to 3 to 2 from left to right. So that's where you can barely see it, 5 to 3 to 2. But now it's not, it's in the ratio of 5 to 3 to 2. It doesn't mean 5 plus 3 plus 2. Like if we add them all up together right now, we get 10. But we're given that EH, this whole thing, is 30. So maybe you can see where a common factor is, but there's a common factor here. In other words, they're in the ratio, which means they have a common factor that it was able to be simplified to 5 to 3 to 2. And so let's take a look at this. So that means that 5x plus 3x plus 2x equals 30. Well, we already kind of added them together. We knew that. And so our common factor is 3, which means that this is 15 long, EF, FG is 9 long, and GH is 6 units long. And so, let's see, find FG. So we found that FG is 3 times 3 or 9. Name the midpoint of EH. Well, I think you can see these two together do equal 15, 9 plus 6. So we do know that F is the midpoint of EH. And there we go.